Welcome everybody to this new Alumni online seminar. It's my pleasure to be with you and be the moderator. My name is Maria Laura Sorrentino. I'm Alumni Officer at IHE Delft, and we offer these talks for alumni and also for all persons interested in the topics that we have. Today we have a very interesting topic that is a focus in Latin America and the Caribbean. For that reason, will be in English. And we are going to talk about navigating Latin America's water crisis, artificial intelligence models and data for a resilient future. This will be a very concise seminar that will show how cutting-edge artificial intelligence tools and advanced models developed and applied by students of IHE Delft and the Escuela Colombiana de Ingeniería Julio Garavito double degree program are transforming a complex data into additional insights for water security. And of course, we will talk about and inform you about the new International Master of Science program, a collaborative initiative between IHE Delft and the Escuela Colombiana de Ingeniería Julio Garavito. We have 4 speakers, so it will be my pleasure to introduce them and to remind you that our program we will start with first talks from Gerald Corzo Perez, that is Associate Professor of Hydroinformatics at IHE Delft, and by Germán Santos, that is Professor at the Escuela Colombiana de Ingeniería Julio Garavito, and he currently serves as full professor, head of Hydraulic Studies Research Group, and director of both Master in Civil Engineer and the institution's graduate programs. After their talks, we will have a 5 minutes for quick questions that you can write in the chat. After that, we will introduce 2 masters alumni that will present their case studies and their thesis. Yes, this seminar will be recorded and the link will be sent to all of you after this presentation. And without losing more time, I would like to give the floor to my colleague, Gerald Corzo Perez.
Thank you so much, Maria Laura. I'm very happy to be able to present a bit some ideas and some let's say some vision on how we are changing due to the changes around the world. So one of the things that is that I wanted to cover in the presentations are the idea of AI, but as well, I want to connect it with the work that we have been doing, around the last 7 years with the Escuela Colombiana Ingeniería, whereby we have a double degree program. And that double degree program, in fact, was phase 1. And now we just started, and we got the good news of this signed agreement with the rectorates of both institutions, last month. And we are on the path of trying to show where do we want to go with this, and what type of research we expect to develop to help Latin America. So kind of the first image that you see in this screen, it's generated by AI. It's this system called Sora, which is part of OpenAI projects. And as you can see on the left side is a recreation. In fact, I give instructions to the AI to tell us a little bit more about how they see the beach in Colombia. And on the right side is the erosion and how it's seen by the AI, which in fact doesn't differ too much from the reality. And it's quite interesting how it sees the erosion close to the humans. Yeah. So what we see in the news right now is the water problems in Latin America, droughts, heat waves. Last year, I think is not something strange for you to hear that the Amazon River basin was in a drought. This is late November 2024, and this is Copernicus here in Europe and the European program telling us that this is a critical situation, that there is lack of water. This implies that we need to optimize our resources. This implies that, in fact, we need more people trained at a different levels to be able to sort out this situation. We have not only droughts, we have also, last 15 days, we have seen floods all around the world. And it's interesting to see now the news, how they match Mexico and China, how we are seeing similar situations where the people are through the streets going in boats. But at the same time, we say that this is also highly related to our environment, and the forests are in a critical situations like the Amazon forest. So what is possible in terms of AI? What you see on the left now is starting to be even more and more advanced. This is AI animations generated. All is completely fake, generated by these AI systems, but it's almost perfect. It's very difficult to differ of these high resolution videos with what is created in reality. However, when you start to go into more technical parts, so the AI starts to generate situations like what you see on the right side. This is the same system, is trying to generate some simulations of scenarios that are happening in real time. Of course, is animation that helps us to generate what are the concepts that they consider in these AI systems. If you start to give more instructions and you want to understand how a water system is going to be used for a city, then you see images like this, integrating environment visions on 3D animations that are quite advanced. But what is behind this? What are we doing in terms of engineering problems? We have basic education in our programs where we understand why the problem is happening, what these water resources are having, droughts, floods, hydrology, what drives the problem. But we are aiming nowadays on this Master of Science on more specific things. What can we do to tackle the problem? How to monitor these problems? How to prevent more problems? What will happen if we do not take an action? And how much time do we have? In the current conditions with this problem. So the Master of Science program right now has been developing in different key areas of water resources. I'm focusing on what we have been working with the double degree, which is more on what we call hydroinformatics and hazards, risk, and climate. And what you see here is when a student comes to this program, we'll start to see a number of topics that are a little bit more advanced than normal. As you can see, is artificial intelligence, computational hydraulics, numerical schemes, organization of water. But we go even further in the last part before you enter into a research part, that is design risk reductions, flood risk management, policy analysis. We see also decision support systems. But all these give us the basis for what I am going to present in this part of this seminar, which is a little bit about thesis research topics from the students. The first two topics that I'm going to talk about are coastal engineering studies. And I am highlighting this because right now Colombia has updated their national plan and actions on coastal erosion. And for me, it was quite interesting to be part of a team that are participating in the cooperation and in the educational programs for the program in Colombia. And after my presentation, Germán will present other MSc topics that also go in line with what we have been doing in artificial intelligence for water resources, but as well, there are some advanced modeling, like for example, Felipe will present on terms of groundwater with 3D simulations, like digital twin kind of representations of systems. So to don't take too much time, because I know that the seminar is, give me 10 minutes. These MSc topics that I'm going to show right now, I presented them for our current coastal engineers and are part of some of what I was mentioning before, Cartagena and Barranquilla region in the north of Colombia, where we see the needs of being able to predict this, how dangerous are these waves, and have enough time to work with them. So one of the things that you can see here in the image are descriptions of Colombia, Caribbean and Pacific. And what you see on the lower part are high resolution images where we can see the path of the river, which in fact carries the sediments that will be sent to the sea and are feeding our coastal area. If you put a reservoir and you stop the sediments, well, your coastal areas start to be affected and reduced. You can have problems also with your fish, so you have food problems. And if also some of these sediments carry nutrients for your plants and your habitat, so you will have a lot of problems. And then here they are identifying all the rivers in each one of the regions, as well as how this contributes to the sediment. Of course, we are quite advanced. There are many infrastructure. There have been millions invested. So now it's even more important to be able to analyze, model these quite complex systems. So aside of that, also we are having right now climate change. So sea level rise is being an important element on the change of our coastal areas. We are losing areas, kilometers, that also represents not only habitat environment, but of course resources for the country. And due to climate change, we have an increase in tropical cyclones, and each one cyclone could have a high impact in the erosion of an area. So what we want to do in these topics is to find high accuracy, improve our lead time, and have less uncertainty. This is one of the topics that we are presenting, which goes into the use of what we call convolutional neural networks. Is the base of what, in fact, I was showing you. These animations are linked to this kind of architecture, that we call it in machine learning. And what we do here is trying to bring a new way to represent the coastal waves and be able to forecast, not using the traditional, but what you can see on the right side, we are proposing not only to advance on the way that we make the model, but also in the last part, what you see on the lower part, these are techniques for interpreting these forecasts. So being able to understand what is behind the machine learning model. So what you can see, these are the expected results. Of course, we look for our students to have publications that will help them to have, well, higher impact when they go out of the Master of Science. But of course, we want to leave things like an open repository of the information of the models, also give some baselines for quantifying how much did we achieve and what is to achieve later. The second topic is more on climate change, long-term shoreline monitoring and forecasting. So this is going for climate change. What you see here also, we have another thing called variational autoencoders, which in fact will help us to learn the patterns of how the shapes of our coastal area are changing on decades. And that's what you can see on the screen, how more or less this system works. And what we are adding again is physics. We want physics informs. We don't want these systems to be blind. And then here we are adding an element on this thesis of how to improve the way that the system is learning and incorporates physics into the learning process. Our case study, in cooperation with the ministry, we have identified a number of areas. So there is a lot of data, there are a lot of information. And therefore, we aim at having kind of dashboards of results, an atlas of how this is changing in the decades, metrics of erosions, and of course, a physics-aware new concept that hopefully will contribute to science to the world. So final remark from this part of artificial intelligence, how we see the future. We understand clearly that we have, on this graph, you can see the balance between AI and the human evolution. So in one side, we see AI outputs and data dependent truth. So in fact, the machine learning is not, it depends on what we are feeding. It will tell us what is right, like our animations. They were not scientifically based, but they can have a very nice representation. So how to validate them? We need to have a critical evaluation. It's our human responsibility to be able to assess that. Like what you see here in this animation, also created by the AI, tell us very similar things. It's like reality, but if you want to apply a solution, you really need to go into details. And the last one is balancing again human needs and the reality. So be aware that these kind of things you can generate with AI. If it's true or not, you can judge yourself. Thank you so much. And with this, I will finish my part of the presentation. We are going to do 2 sequence of presentations. So now I will give the floor to Germán. Yeah. And then we will give a space for questions for this part. Germán, can you hear me?
Yes. I just one moment. I'm going to share the screen. Okay. Thank you very much, Maria Laura, for giving us the opportunity to show our cooperation with IHE. I'm not going to do some details, but we have done many things, many activities together. We have organized short courses, we have done some research, we have done some data science competitions, we have some joint publications in very prestigious journal, and we have done some presentation in a very important seminars. Gerald talk about our double degree. I would like to talk a little bit more about that. We started in 2020 our program, and as Gerald said, it was more in wire science engineering with specialization in hydroinformatics, but with the changes that have been in IHE Delft, we have a new program. That is a Master of Science in Wire Sustainable Development, and for me it's a pleasure to present that. And as you can see the QR code that you can go to the web page in the Escuela to see the details of the program. The double degree, then you get a master degree in IHE Delft, and in Colombia, you have a Magister in Ingeniería Civil con énfasis en recursos hidráulicos y medio ambiente. So far, digamos, in this first phase, we have 10 graduates. For us, it's really glad to see that they hold positions in very important consortium firms, government agencies, and wider authorities, both national and international, demonstrating the prestige and wide-ranging job opportunities offered by the double degree. They are valued for their problem-solving abilities, application and sophistication, the computational tools, generation of program codes, and application of proficiency in technical English. I would like to give a glance of the graduates and their current placement. I'm not going to go into detail, but Camilo Andres is going to give us with more detail what he did. And you can see where he's working. I'm not going to read, but you can see it. He works in natural language processing in Bolivia. A very interesting topic. Carlos Alfredo Mesa worked in the exploration of the impact of trees on pipe failure using data mining techniques. It's a very advanced technique in Netherlands. Karel Sanchez worked in machine learning for characterizing, tracking, and special temporal drought events in Central America dry corridor. Felipe Sierra, he's going to talk later about the groundwater in a place here in Colombia. It's very important topic too. Andrés Julián Ruiz works in analysis of special temporal rainfall objects in hydrological ensembles, forecast predictions, and Cindy use SPI and hydrological modeling to analyze the climate change effects on droughts in Romania. Fernando Montejo works in reservoir operation, optimization to reduce the pollution in Lempa River in El Salvador. Laura Viviana Garzón works in analysis and classification of water distribution network in Den Haag. Felipe Peñuela works in agent-based modeling for assessing potential water-related conflicts case in Kenya. And Jessica Wilches works in assessment of mine spillage effects on receiving waters, hydrodynamic and water quality studies in Mexico. You can see our students have worked in a very interesting topic, and they are working in prestigious institutions across Europe and in Colombia. And we like to present two cases so you can see in more detail what we can do with this program. Thank you very much, and I let Gerald to present our students.
Okay. Yeah, thank you, Germán. I think it was quite a nice summary of the activities with Escuela. So I think we have the idea is to have a space for questions, so we don't jump directly. So Maria Laura.
So I would like to invite any person who has questions, if you can write it in the chat so I can read it, and Professor Germán or Gerald can address the question. We are going to have 5 minutes, and after we are going to continue. I don't see any questions, Gerald, so I will suggest that you go ahead with the presentation, and we have all the questions at the end, and I invite you to write the questions in the chat, please.
Perfect. Okay. So yeah, well, I think it is time for Camilo and Felipe. I will, briefly talk about, well, Camilo. They started in the Master of Science. They started in Colombia with the Escuela Colombiana de Ingeniería, and of course, he has a degree in civil engineering, and he came, in fact, with a lot of experience in water resources, but in general, there was a moment on the Master of Science thesis where there was a discussion on, there was an international organization called Stockholm Environmental Institute, where there was these crazy ideas with Hector, and he is right now in Stanford, by the way, but the end result with Camilo was going into an area which is, if for some of you hear about natural language processing science, quite strange. But so I will think first give the floor to Camilo, and then we will talk about Felipe. So Camilo, floor is yours. You can.
Okay, Gerald, thank you so much for the introduction. So I'm just gonna share my screen. Okay, thank you so much. What I'm going to talk about in this seminar is about decision-making based on AI-driven linguistic analysis, based on the thesis that Dr. Germán Santos already introduced a little bit. So to start with that, as Gerald mentioned, some of the topics that we can find in the internet about water in Latin America could be found in news, but also this could be found in social media, such as X, that have become an open source of communication in which anyone can give their opinion of any topic, or where we can find information about any topic in the internet. Knowing that and understanding this, what we can do is get this information from the internet and use it as valuable information for decision-making processes. So the hypothesis thesis in the thesis was The use of natural language processing in unexplored digital information sources, as I mentioned, public and social media, could complement a watershed characterization and allows to understand the problems that are in a river basin or a watershed as well as possible. So, what is natural language processing? First, this is a branch of artificial intelligence and it combines computational linguistics, data rule-based modeling of human language with the statistical machine learning and deep learning models. And together, these technologies enable computers to process this human language in the form of text or voice data to understand its full meaning according with the speaker or the writer's intention, perception, and sentiment. So some real-world applications are spam detections in the emails, also matching translations to another language, text summarization, and public and social media sentiment analysis. That was the topic that I developed in the thesis. The case study corresponds to La Paz Choqueyapu River Basin in Bolivia. This is one of the 14 the Bolivia National Watershed Plan, that it's one that it's been developing since 2020. And it's also a subbasin of the Amazon Basin with a surface of 489 square kilometers with some principal municipalities that are El Alto and La Paz. And for some hydrological context, the hydrologic year starts in October and with a rainy period between October and March and a dry period between May and August. So the application of natural language processing for the thesis consisted of identifying keywords like the water bodies that we have in the basin, systems like river, lakes, reservoirs, wastewater treatment plants, aqueducts, and also which are the authorities that are in charge of water resources in the river basin, municipalities, and any keyword that could help us to characterize what is happening in river basin. Also floods, drought, and as you can know, any word that could help us to understand what is happening there. And then each keyword was extracted using web scraping and was searched in the different newspapers and also in X to see what is happening there. Then this information from the newspapers and from X was stored in a structured data. So this data was unstructured, and then to do some analysis, it's very important to have it structured. Then this data, once that is structured, was split into two sets, one the training data and the other one the test data. So first, the trained data comes with a pre-processing of information that consists on some techniques like tokenization, the stop word removal, that are words that are not giving any sentiment or perception to the document, named entity recognition to get information like names, municipalities, dates, values, and word embedding that was converting these words into a numerical or a vector that could help us to characterize it and also do some analysis with them. Then once this is done, the machine learning text classification models were tested to see which one works better for our case study. And then the application of sentiment analysis was done to see if the text that was extracted is positive with a value of 1, or it was negative, or the perception of the text was bad with a value of 0. And then once this is done, some metrics evaluation were applied to see which model works better. I will not enter into much detail of this, but for the extraction and storage of information, this was developed in Python. Some of the libraries that could use for the web scraping are Beautiful Sulfur, Selenium. Before we have a package in Python that was TweetPy that helps to get information from X. This is based on the inspection of HTML web page code to extract the text that we want. And for the structured data, we have information like the title of the article, the content, the reference link, the date, and in which newspaper, or if it was from X, the information. Also, it's very important to do some exploratory analysis of the information, how the data is distributed per year, per month. From the articles, we've got 3,393 articles in this analysis. Also, we can check per year or month how many articles do we have to check what happened on that date. And also we can do the analysis by word, by keywords. For example, here in precipitation, that it's really according to what we see in the hydrological period, that most of the articles that talk about rainy are happening in the rainy season. For the word embedding, as I mentioned, the main idea is that two words with similar meaning share a similar context and then a similar vector representation. This is the main idea of the word2vec and doc2vec libraries that I used for this analysis. Also, the semantic information is preserved. So what is happening is that each word from the whole vocabulary that we have in the whole data set after the stop word removal, characterization, and etc., becomes a vector, and the word2vec maintains the semantic. So in this case, two words that have a similar context will have a similar vector representation. In this case, we have that the dimensions of this word2vec model output will be the size of the vocabulary plus the dimensions of the vector. In this case, the dimensions, the model should be calibrated. So you can have 30 dimensions or 100 dimensions. It depends according to if we have very different topics, or if, in this case, as it is a similar topic that is water resources, we can have like a smaller dimension. Also, it was checked that if the best application that we can do was supervised modeling versus unsupervised learning. So the supervised learning is that you have the input data and you know what is the output that you want. So for example, in this case, the text, we know, for example, if it's negative, we already know the output, and this is the application that we do. But in unsupervised learning, that is more a cluster algorithm, you don't know which one was the output. So we also applied that, but we didn't find very good results in the classification of positive and negative text articles. The text classification algorithms that was used in this thesis was the logistic regression, the multinomial naive Bayes, and the support vector machines with some linear kernel and with some also RBF kernels to see how the classification was done for the different articles and texts. In order to get the results and see which algorithm was the best, we use 4 metrics. One is accuracy, that is most useful when target data is balanced. In this case, we have 2 target data, positive or negative. But in this case, as we know, normally when we publish something in X or in the news that are related towards resources management, typically the sentiment is more negative than positive. So we have more articles classified as negative as positive. So accuracy could not be the best option. Also, precision and recall are better metrics for unbalanced target data. That is the case that we have in this case study. And F-score, it's a metric that summarizes precision and recall. So using the grid search CB library in Python for calibration, we can ask for an objective function that in this case was maximize the F-score metrics. So what we found is that the support vector machine with linear kernel was the one that works better in this case for the F-score. Also, we have the logistic regression, but we found that the precision also was better in support vector machine linear kernel. And once the model was selected, what we do is to use the train and test data to see what is happening and how it was classifying the information, knowing our target, that if it was positive or negative, and we compare the results with a previous library that we have for sentiment analysis in Spanish that was called Spanish Sentiment Analysis Library. And as you can see, however, the precision is some kind of good, but not the best in the Spanish sentiment analysis. We improved that, and most of it in the recall and the F-score for the positive articles. So this is also something that was good to improve what was developed before. And then also what we can do with the results is grouping this data by sentiment. So with that, we can do some multi-scale analysis for negative and positive for different contexts like the municipalities, checks which ones are the most negative words. For example, agua potable, emergency, rationing, water supply, etc. Also, we can do in a more bigger scale, like a river basin, or also in a specific water body like a river or a lake, to see what is the sentiment and what are the perceptions of people, to see and inform the decision makers which are the perceptions and where they should focus to do some interventions in the basin. And to finalize some conclusions and recommendations, de hecho que ya prior contamination is the community's top concern, as it's El Alto main wastewater collector and also the one that they used for water supply. Public perception of this contamination improved during the pandemic, likely due to maybe health at construction industrial activity and new wastewater treatment plants. But it's also important to assess the current community perception to see if this trend continues or if not. Beyond pollution, increased river flow during rainy seasons and the result flood risk is a major community fear. But if we see the whole country, drought concerns prevalent, as agriculture is one of the main activities and also mining. And by grouping the results as positive or negatives, the most frequent topics or words can be determined at multiple scales, as I mentioned, to inform the decision making based also in citizen science. And while AI tools offer powerful text analysis, the validation of a subject matter expert is crucial. AI is a valuable tool, but it requires informed application and expert knowledge to see if what AI is giving us it's true or not. So this is what I wanted to finish the presentation. So also if you have any questions, you can write it in the chat. And then if you want to discuss more about this topic of AI, how to use for decision making, you can contact me on my email. So thank you.
Excellent. Thank you very much, Camilo. Quite nice presentation, very clear. We will do first the presentation of Felipe, and then we go for the questions. So we have questions for both of you at the same time. I think that's the best. Yeah, well, Felipe, I think they have shared in the chat your profile, so I don't have too much to say. That it was also very nice seeing your topic and your motivation. And your dedication to doing modeling in groundwater. So I'm really happy to have you here. So please, Felipe, floor is yours.
Thank you so much. Thank you for your invitation. Hello to everyone. So I will start to share my screen. Okay. Please let me know. Oh.
Yes, we can see it now. But
okay.
Presentation.
So
mode. And now it's presentation. So good.
Okay. Thank you so much. So I will show the results of my thesis project, which is related to groundwater modeling for identifying sustainable abstraction alternatives in the Sotaquira River Basin in Colombia. This is a thesis project I was developing with IHE and both with Escuela Colombiana Ingeniería in the double degree program I was doing in 2020. Something about me, I'm a hydrogeologist, hydraulic engineer and hydrologist. And as a civil engineer, I developed my professional skills in the water resources. And that's why I developed a master's degree in water resources and environment. And then in hydroinformatics in IHE Delft to finally do my master's degree in hydrogeology in the University of Birmingham in the UK. Okay, I will start to talk about my thesis project, which is related to the climatic variability, which is intense in the water resources in Colombia. And such is the case of the Chicamocha River Basin, which is located in central part of Colombia in the Boyacá department. And most exactly, we will be talking about the Sotaquira River Basin which will be helpful to try to find additional water resources, mainly groundwater. So in the case of the Chicamocha River Basin, the climatic variability is decreasing the water flows by 30%. So this system, this basin has a high stress. We have also water used for irrigation, for energy demands. Water is used for energy demands. The water is also used for water supply. So the system and the main Chicarmocha River system like that, it's overstressed. And that's why we are trying to find another basin, which is in a sub-basin from the main Chicarmocha River, to be used to take the groundwater to supply energy demands. In the case of the supplies, the energy demands, this is increasing in the future, the need of supply by 300 liters per second in the future. So this thesis project is about to try to find how to supply these 300 liters per second in the future. So to perform this analysis, we need to perform a low flow analysis to try to find a period selection to perform this analysis. And then we will be doing a recharge computation and hydrogeologic framework to construct a geological model, a groundwater modeling, which will be calibrated, and then to develop an alternative analysis to select this alternative and to try to find which will be the higher flow that can be extracted from the groundwater from this sub-basin to supply the energy. We'll be doing a further analysis in land subsidence, which will be quite short, but yeah, it's because if we extract too much groundwater in some systems, we will have some another additional problems, which could be the subsidence. So the first step was the data preparation. This data preparation, we use some information about the daily discharge, precipitation discharge, from a station located inside of this basin, of the Sotaquira River Basin. And we can highlight some initial finds, in which is we have from January to April period low flows. Then we will have high flows in April to May, and October and November will be again high flows. And so this information will be used for calibrate a model using the base flow in the future. Also, we have precipitation, which shows that we will have a significant period of 39 years. It can be used for do this analysis. Also, we have information about temperatures from climatological stations, which records the temperature, which can be extrapolated to the whole basin using some regional methods to create rasters of temperatures. Also, we have another information, which is the DTM of 12.5 meters of resolution from the Alaska Satellite Facility. Soil map and coverage maps from IGAC Institute from Colombia, a cartography entity from Colombia. And also we have geological maps from the Geological Survey of Colombia, which is the Colombian entity which it's try to find geological behavior of the whole region. So with these geological maps, we create a model, which is a geological model in which you can discretize to create a groundwater model. So this is one of the main information we have, because it's showing how it will be changing the hydraulic conductivity in the whole region. We can see that we have different formations, but I want to highlight the lower part of this basin of the Sotaquira River. It's quaternary, it's an alluvial deposits in which can be stored groundwater, and it's close to the surface. And also we perform some geophysical exploration with vertical electrical surveys to try to find how it's behaving the stratigraphy in the main formations. And the most important was in the lower part, in which the groundwater is too close in the quaternary deposits, and it's showing how it's behaving. Also, we have some artesian wells just to check how deep is the water table, which is showing that it's located about 3 or 4 meters below the surface. About the analysis period of the low flows, in the Chicamocha River Basin, we have some critical years, which is 1992, 1997, but the most critical was 1992. This is coincident with the global dry periods. We have also 1992, and in Colombia we have some years. And the coincidence is that we have information from this critical year, which is 1992. So this year was the period of 1990 to 1993 was selected for this analysis. Also from the La Reforma gauge station, which is located in the Chicamocha River Basin, we can perform an analysis to try to find the lowest periods, low flow periods, and it's coincident with the Sotaqueira River Basin, which is the period January to March. So the selected season for the analysis is January to April. Also, we perform the recharge computation using a continuous simulation model. The results, which performs water balance at a daily scale and can be compared with the observed flows of the in the basin, in the Sotaqueira River Basin. For the period selected, which is 1992 to 1992, we can see that we have some, after calibration, we can find some similarity between the observed and the computed flows. So this was used to estimate the recharge, because in between the model, we can find the percolation. So this is a correlation between the observer and the computer, which is 0.667. And we can see how it's behaving the recharge in relationship to the precipitation. And of course, we will be finding that in the dry periods, we will not having recharge, which will be the most critical periods of this system. Once we have the recharge, we perform 2 models. The first model is the parent model, and will be the model of the full basin, the whole basin, just to check how will be the water balance at the regional scale. We'll be using some initial parameters and boundary conditions from previous studies and the analysis of the research. I want to highlight here that we'll have 10 layers from 50 meters to 170 meters of depth, which will be the model. This analysis was performed using Model Muse, open source tools, and FlowPy. FlowPy we use was to calibrate and to perform a sensitivity analysis of the main parameters. Also, to try to find and to optimize the analysis, we try to find a potential groundwater zones using remote sensing and GIS, using some weights of different parameters we can find in the basin, which are the coverage, soils, slopes, elevation dam, precipitation, and drainage density. We can find that by coincidence, the lower part of the basin in which are located the alluvial fans, the quaternary deposits, are the highest potential groundwater zone. So this region was selected to perform the child model. So this was the child model, which is just a part of the big groundwater model. And also by using the geological model, it was performed or created the groundwater flow model. I want to show here just some results of the water budget, but I want to highlight here that we have some high interactions between groundwater and surface water. So if we try to get or to extract groundwater from this system, we can have some effects in the base flow on these rivers that are flowing in the lower part of the basin. So to perform the the calibration of the model. Sensitivity analysis was performed using Python package, which is FlowPy, and using the Sobel sequence sensitive analysis and the ECIJG function, we could find that the recharge and the hydraulic conductivity in the first layer was the most sensitive parameters and was used to perform this calibration. The calibration was performed using the streamflow package from Modflow, just to try to find the conductance that will let inflow enough base flow, just to calibrate with the separation of the base flow from the system, from the observer groundwater flows. And this is the results we got, which is most suitable for low flows also. And this was the calibration that was performed. As we didn't have or only artesian wells, we cannot perform pumping tests, for example, but only the calibration through this package. This is the results of the water balance. I will not stop not too much in here. And to perform the analysis abstraction of the alternatives of scenarios, 6 wells were performed. Were located in this lower part when there we have higher potential of groundwater, up to 80 meters of depth, which is mostly in the second layer of this model. So we have 6 alternatives. The first alternative was about taking only 150 liters per second in total for all these wells proposed in the first 4 months of each year. So we'll have a drawdown that we'll have every year. We'll have a recovery, and we will have an effect directly in the base flow. That we will have here base flow comparison between the initial condition and the abstracted condition, and we can find here that we'll have a drawdown for width of 8 meters, a base flow reduction of 15%, and a minimal base flow of 475 liters per second. So that was the first scenario. The second one was 150 liters per second in 16 months. So it's the full year and plus the first 4 months of the next year. And we will be taking this discharge in the whole time. So we'll have higher stress, we'll have more drawdown, a reduction of the base flow for 24%, and a minimum base flow of 428 liters per second. Second alternative is just to take the required abstraction of 300 liters per second, also in the 4 months of each year, first 4 months of each year, in which we will be having a drawdown of 13.5 meters. We'll have a reduction of the base flow of 29% and a base flow of 275 liters per second. So we have higher stress taken by taking groundwater in the system by taking these 300 liters per second. Also, we have abstraction of 300 liters per second in the 16 months for the full period. And the maximum drawdown is 16 meters. We will be having a base flow reduction of 45%, which is also the half of the reduction of the base flow in the streams. And we will having a base flow of 222 liters per second. So we did also a final check, which is the abstraction of 150 liters per second and only the first period of 1992, in which we'll be having a reduction or a drawdown of 14 meters, a base flow reduction of 15%, and a minimum base flow of 424 liters per second. Also, we check a recovery. We perform a recovery analysis in which we could find that the recovery period, once we stop pumping, is 2 months. Take 2 months to recover the the water table to the initial conditions. So about the alternative selection, we will use the concept of environmental flows, which in this case for the Sotaquira, we are basing the environmental flows using the ENA methodology from the IDEAM, which is a methodology accepted here in Colombia. We have that the environmental flow is 390 liters per second. And if we check the results of our alternatives that we perform, we can see that the reduced base flow which should be higher than the environmental flow. So the alternative one, it can be option 1 or 2, can be used to extract the groundwater. So the results of this analysis showing that this system cannot supply the whole requirements of groundwater, which is 300 liters per second, but can supply and a half of this demand. Also, I was performing a land subsidence analysis in a 20 years period because there is an aquifer in the middle, just 100 meters below the surface in the region, because these are some quaternary deposits, and we could find that it's expected that subsidence of 4 centimeters taking 150 liters per second in 20 years, and it's expected a subsidence of 11 centimeters in the 20 years period of 300 liters per second. So it's acceptable, this kind of subsidence in the system. So I was talking to you. It cannot be taken the whole requirements of groundwater to supply the water demands, but we can take on a half, and we should try to find another alternatives to supply these increasing groundwater demands. But this basin can supply some part of these requirements. So thank you so much. This is my presentation. So you have any questions, please let me know.
Thank you very much, Felipe. Thank you very much, Camilo, and Professor Germán Santos and Dr. Gerald Corzo Perez for the good presentations. And I would like to take a few minutes more for the questions that we have received, and also invite the ones who would like to write the questions or new questions in the chat. Please go ahead. We are going to extend this seminar a little bit more. The first question comes from Jaime Vargas, and the question is, Choquelapu River is highly polluted and is a serious problem to the region. What is the current situation of the project and how is helping to the decision makers, and if it is being applied? Gerald, please say who will be the best person to answer.
Thank you. So I think Camilo.
Yes. Thank you, Jaime, for your question. The current situation is that, okay, the river is still polluted. It's very difficult to apply some different techniques in order to get some better water quality in the river. However, just to mention to you, this thesis was applied in the director's plan of La Paz Choqueyapo River Basin that it's already online. It was published in 2022 and have a huge analysis of the river basin, which are the alternatives that should be applied, which are the problems according to the perception of people and what is happening in the basin. And also we use the inputs from these questionnaires, from this analysis from the media, as an input for a tool that we have in SEI that it's called washed flows. And also we develop a WIP model in order to understand the whole river basin and see which are the best alternatives. So now on, as the plan is already published, I think that the Ministerio de Medio Ambiente y Agua and the different water authorities are in charge of applying maybe these alternatives and see what's coming for the future.
As you know, I love networking, so may I allow to say that Jaime, is an alumnus of Bolivia and Camilo from Colombia. So later, if you wish, I can put you in contact. And I don't remember all the nationalities and all the names, but Jaime's I remember. Isabel Cristina Hurtado Sanchez has another question, and the question is, it is possible to know whether reforestation could improve flows in the basin?
And I think that one for Felipe.
Yeah, of course, it can help to improve because we'll take in more water stored in the soil, so it can be performed. However, by checking the coverage, these covers are not so affected in the Sotaquira River Basin. We have mainly natural coverage. However, we can, in the lower part, which are some fields to um, having farms and some other uses, land uses, we can perform this kind of restoration just to improve or retain more water in the soil, in the unsaturated zone. So yeah, it can be applied. However, the requirements of the groundwater are so high, so high. So this basin is not enough to supply these requirements of groundwater. So it's better to check another basin, check another places where to take this water, maybe construct some dams or some ponds where to store this water just to supply in the dry periods.
Thank you very much. Professor Álvaro Padilla from Cochabamba, Bolivia, also alumnus, would like to send for the seminar. Thank you very much, Álvaro. The spirits presented are really impressive, important, and innovative. We surely will be contacting Camilo and Gerald to discuss with them details of a project dealing with the ecological quality of the upper basin of the Madeira River Basin. We are just, oh, I get lost. We are just preparing within the Bolivian University and national and international water experts, some of them IHE alumni. Hopefully, soon we will propose a seminar like this one. Thank you very much, and I will contact all of you. I don't see more questions, so I will open the floor to the speakers for the final words. Professor Germán Santos, if you would like to start. We can have 5 minutes extra.
Okay. Well, thank you very much, Maria Laura, for us. It was really a pleasure to show our work and see in the future what we can do. And we hope that many students from Latin America do the double degree program. That is our wish, and we hope have many people from some other countries too. And thank you, Camilo and Felipe, to support us in this part. And actually, we are really close to all of the students, and I thank you to them. Or thank you to Gerald too, and of course to Maria Laura for this opportunity.
It's my great pleasure to organize this for all of you. Felipe, would you like to say your brief last words?
No, thank you. Thank you so much for this invitation. I'm so happy to share these results I got in a so interesting thesis project. I hope well, too many students take this kind of program because are so good. There are a lot of knowledge you can learn from this kind of programs in the future. So thank you so
Thank you
much.
very much, Felipe, for your participation. Camilo, the microphone is yours.
Thank you, Maria Laura, Dr. Germán, and Dr. Gerald for the invitation to the seminar. Also, as Felipe mentioned, it is a great opportunity to also get more knowledge about the different studies that IHE and Escuela Colombiana Ingeniería are doing together in water resources management and the innovation and application of new technologies. And also, it will be great to connect with different students and alumni like Alvaro and Jaime to discuss more about these topics, and also with anyone that is interested on this concept of citizen science and how to apply AI for better planning and decision making and more informed water management. So thank you so much.
Thank you very much. And last but not least, Dr. Gerald Corzo Perez.
Yep. Thank you so much, Maria Laura, for all this support in generating this seminar in such a short time, and I'm really happy to see that all the topics and everything seems to be quite current. So just hopefully there will be many people interested in these topics. We have quite a nice number of alumni with impact on different places in the world. So really just less to motivate everyone with this program with Germán and others. We will be trying to make the best out of your experience here in the Netherlands and in Colombia. So thank you, Maria Laura.
Thank you very much to all speakers for the great presentations, to the attendees, and last but not least, I would like to comment that there is some information of the double degree program at the page of IHE Delft, that the information will be increased in the coming days with more details. So thank you very much, and hope to see you as a speaker or as an attendee in the coming seminars. And last but not least, to our colleague Vijay for all the technical support. Thank you very much, and see you in the next opportunity. Thank you very much to all, and all the best for the double degree.
Thank you all. Bye bye.
Thank you. Thank you so much. Bye.
Bye bye.
Thank you. Bye bye.